Okay, we did the first 3 on Friday. Is that right? Okay, so we've already talked about point, line, plane. Okay, so collinear. Oops. All right. So what I want to do on the collinear is I want you to split it like this. We're going to give an example and a non-example. Okay, so what does the definition say about collinear? Okay, they're points on the same line. So what I'm going to do is I'm just going to draw a line right here. You put it on the wrong spot. That's all right. Okay, so collinear, that's an example. Got a line, put the 3 points on there. A, B, and C are all on the same line. So on a non-example, I'm going to do like this. A, B, and then put C down here somewhere. Okay, can I draw a single line that goes through all 3 of these points at the same time?
No.
Nope. So I would say A, B, and C are non-collinear because you cannot draw one line that goes through all 3 of them at the same time. Okay, coplanar, I want to do the same thing. We're going to do an example and then a non-example. Let's. Okay, so coplanar means there are points on the same plane. All right, so the way we're going to do that is like this. I'm going to draw a rectangular prism like that thing that we made yesterday. Okay? Bless you. And I'm definitely not an artist. Okay? I don't claim to be. I'm not one at all. But so when I draw a rectangular prism, I draw a rectangle. Then I draw another rectangle that's the same size, but that's offset. So like this. And then just connect corners like that. Okay, so this point, this point, this point, and this point. These are what we would call coplanar. Okay? Because again, what does coplanar mean? Points on the same plane. And what is a plane? It's like a flat surface, right? Like your desktop is a plane. So being coplanar means they're all on the same flat surface. Are all 4 of those points on the same flat surface? Yep, they're all here on the top, okay? Now, let's talk about draw a non-example. So I'm going to do the same thing. I'm going to draw a rectangular prism here. Yeah, this one got all jacked up. It's terrible. Okay, so would be like this point, this point, this point, and then boom, this point down here. I mean, that's not the only way I could do it. I could do it a bunch of different ways, but that's one example or non-example of being coplanar. So think about it. With those 3 points, or 4 points, I should say, is there any way that you could get one flat surface that can go through all 4 of those at the same time? No, because up here, these would have to be here, then it would have to bend down to get to this point right here. So there's no way You could have one flat surface that goes through all four of those at the same time. So this is what we call being non-coplanar. All right, next, what does parallel mean?
Same.
What does it say?
Two lines in the same plane that never intersect.
Two lines in the same plane that never intersect. Okay, so what I want to do here is we're going to draw another rectangular prism. Okay, so like this line right here, this line right here. Assume that is a true rectangular prism. Those lines are parallel right there. Okay, next one is perpendicular. What does perpendicular mean? Okay, good. All right, so what I want to do here, we're going to do two things. First of all, let's draw another rectangular prism real quick. Okay, so assuming that this is like a true rectangular prism, again, here that I drew everything perfectly, this right here, these would be perpendicular. This would be 90 degrees right here. That's what we're talking about. It's where these two lines meet up to make a 90-degree angle. Okay, and also out next here, I want you to just do it like this. Sorry, that thing is lagging for some reason. Come on. There it goes. Did you get it? Okay. Next side. Okay. So skew lines. Did we talk about skew lines yesterday? I can't remember. There's a couple where I just didn't get to it. Okay, so we're going to do the same thing here. We're going to draw a rectangular prism. Wish I could draw this better. Yeah. Harder I try, the worse it gets. All right. Okay, so skew lines are two lines that are in a different plane but that never intersect. Okay, I want you to write this down. I want you to add this to that. They are not parallel, but they also do not intersect. Okay, so an example of skew would be like this line right here and this line right here. So think about it like on this Kleenex box right here, okay? So skew lines are lines that are not parallel, but they also do not intersect. So if you think about this line right here, okay, it's running like this. And you have this line on the back that's going up and down like this. Are these two lines ever going to hit each other? You have like a line Let me get some pencils here or something. So you have a line like this, and you have a line in the back right here. So this one's running like this one's going up and down. Are these two lines ever going to hit each other like this? Nope. But would we say that these two lines are parallel? Are these two lines parallel? Nope. Okay. Bless you. So these are not parallel, and they're not going to hit each other. So this is what we call being skewed. And that's the same thing we drew that like that. It's like this. Those are not going to hit each other. All right. Next thing is space. So what is space? It's every single point that exists. So it's all the points in this room. It's all the points outside of here. It's all the points in the entire universe. So I have no idea how to draw that. So we're just going to leave it blank and just say it's everything. Okay? All right, a line segment. So what is a line segment?
A piece of a line with 2 endpoints.
Good, a piece of a line with 2 endpoints. So it's going to look like this. So how is a line segment different than just a line? Good. A line is infinite. It keeps on going forever in both directions. A line segment stops. It has a starting point and a stopping point. Okay, so it's got 2 endpoints. All right, the way we do this is we would write it like this. Okay, if we were naming it. That right there is the symbol we use for line segment. It's just a bar, no arrowheads. Okay, array. What's array? Okay, it's a piece of a line with 1 endpoint that extends forever in the other direction. So it's like this. You have an endpoint, and then the line goes there, and there's an arrowhead on this side. Okay? So what I'm going to do is I'm going to name this. I'm going to call that endpoint point M, and I'm going to name a point, just call out a point somewhere on that ray, call it point P. Now remember, is M and P the only points on that ray? No. There's an infinite amount. Those are just the 2 that we happen to call out, that we named. I mean, M is important. It's the end point. But P is just a random point on there that we just called out and named it. All right, so here's how you name a ray. It's going to look like this, MP, with 1 arrowhead on it. Now, on a ray, when you're naming it, the order matters. For everything else we've talked about so far, on a line and a line segment, for what we're doing right now, that doesn't matter. But on an array, the order does matter. Okay? The endpoints, let's just fit this in wherever we can. The endpoint is always first. The endpoint is always first. So, if I saw this ray right here, MP, and I named it like this, PM, if I tried to name this ray like this with PM, that would be the wrong way to name it, okay? So draw this on here and put the slash through it. Say, do not name it like this. This way is good. This way is bad. See? And all I'm saying here is just make sure that the end point is the first letter. Don't put this point out here as the first letter. It's not the same thing. Okay, so what does bisect mean? Cut exactly in half. So let's say I have a line segment that is 10 inches. Okay, and I'm going to bisect it. Cut it exactly in half. So if I cut it exactly in half, how small or how long are those other 2 pieces? They're both 5 inches. Okay, or let's say I have an angle that's 50 degrees. Let's say I bisect it like this. This is my bisector. Okay, so I've got this angle I started off with is 50 degrees, then I put in a bisector. It bisected it. How big are these two angles right here? They're both 25 degrees. Okay, next is the midpoint, which the midpoint is tied very closely to bisect. Bisect is like the action. Midpoint is like where it actually happens at. So it's like this. If you have a segment that is 8 inches and you have each one of these is 4 inches, this right here is the midpoint. Okay, and then the final thing here is an angle. So what's an angle?
Two rays that have a common endpoint.
2 rays that have a common endpoint. Good. So I'm going to do is I'm going to draw one ray. Okay, so we've got a ray here. I'm going to draw another ray that starts from the same endpoint. And when we do that, we have 2 rays that start from the same endpoint. We create an angle. Okay, and I'm going to put point B here, point A here, and point C here. Okay, I could call this angle BAC. I could call it angle CAB. I could not call it angle ABC. And we'll definitely talk more about that later, but just to get that in here for now.